find a general solution to the given equation. This is a differential equation with constant coefficient, and on the left hand side we have two functions that we can guess the form. So we will use the superposition principle. First we will find the homogeneous solution. For that, we have the auxiliary equation of the form third derivative will be r cubed plus 3r squared minus 9r plus 5 equal to 0. This is a cubic equation. I will use the calculator. Hit y equal to and enter the function. We can just say that x cubed plus 3x squared minus 9x plus 5, and we have the graph of the function. It will go through -5 and it touches the x-axis at 1. So we say multiplicity of 2 when x equal to 1 and multiplicity of 1 when x equal to -5, and that's what we have. Right. So we say r equal to 1 multiplicity of 2 and then r equal to -5 multiplicity of 1. We can also, with that we say r minus 1 squared, and r equal to -5, we say r plus 5. If we multiply it out, we should have the left hand side of the equation. You need to do that. So I will write corresponding to that, there will be two solutions corresponding to r equal to 1, one of which is e to the 1x, but let's just say e to the x. Let that be y1. Y2, we also e to the x, but if we do that, it will not be linearly independent. So I will multiply an x here. That will be y2, and y3 will correspond to -5, so e equal to -5x. And we have the general solution or particular solution, complementary solution. C1 y1, C1 e to the x, C2 x e to the x, and C3 e to the -5x. So that is the homogeneous solution. Now we go to a particular solution. And there are two functions, e to -x we can guess, and 3 sin x we can also guess. But first, let's just do that for e to the -x. So the particular solution will take the form of ae to the -x. We take the derivative, second and third derivative, and then we substitute into the equation. Derivative is -a to the -x. Second and third derivative will follow. And then third derivative. Then we substitute into the equation. Y cubed plus 3y second derivative, 9y derivative, plus 5y equal to 7 e to -x. Right. So we will have -ae to the -x 3 times ae to the -x minus 9 negative a e to the negative x, 5 times the function a e to the negative x equal to 7 e to the negative x. The left hand side we have 3 plus 9 plus 5, that's 17 minus 1, so 16a e to negative x equals 7 e to the negative x. So we can see that a is 7 over 16. Because of that, we can get the particular solution is 7 over 16 e to the negative x, and that is the first particular solution. The second particular solution will be a little bit more complicated because we have two functions. We see, right? So particular solution 2. This time we will guess for 3 sine x. So the particular solution, I will use Q instead, and we will have a cosine x plus b sine x. And now we will check the derivatives. The first derivative will be equal to negative a sine x plus b cosine x. The second derivative, negative a cosine x, negative b sine x. The third derivative will be negative a sine x, negative b cosine x. I'm sorry, this should be a positive. A sine x. Right, now we substitute into the equation. Our original equation, the right hand side is going to be 3 sine x. So let's get that here. And we will substitute into the equation. Right. So first we have the third derivative, give us a sine x minus b cosine x. 3 times the second derivative, negative a cosine x minus b sine x, minus 9 times the derivative, negative a sine x plus b cosine x, plus 5 times the function a cosine b sine equal to 3 sine x. Right. Now on the left hand side we have either sine or cosine for sine x. We combine like terms. We have a sine x here, 3, and negative b sine x, negative 9, and a sine x, and then 5, and b sine x. Put all of that together and factor out the sign. We have a minus 3b plus 9a plus 5b. That is for sine x. And then we have cosine x. We underline all the cosine x. Sorry, not on the last one. And cosine x. So we're going to have negative b, negative 3a, negative 3b, sorry, 9b, not 3. And then 5a. The right hand side is 3 sine x. Undetermined coefficient, the sine x, coefficient of sine x must be equal to 3, and the coefficient of cosine x must be equal to 0. So this coefficient here has to be equal to 3. So we will write combined line terms. We should have 10a plus 2b equal to 3. And then the coefficient of cosine x, there's no cosine x on the right hand side. So that must be equal to 0. And combined line terms again, we have 2a minus 10b equal to 0. And we have this system of equation. I will use the calculator again. I will type that into a 2 by 3 matrix and then do the reduced row echelon form. So second, that go to here, reduced row echelon form, and then we put the matrix 2 by 3 and hit alpha, zoom, and then let's say 2 by 3 matrix, and pretty much just enter the number. The negative, not the subtract sign. This is the subtract, and we're not using that. Equal to 0. And we hit enter, and we have the solution. We convert that into fraction. Right. So with that, we can say A is equal to 15 over 52, and B equal to 3 over 52. So let's just say we use the reduced row echelon form for system of equation. We will have A equal to 15 over 52, and B is 3 over 52. All right. And then we can say the particular solution is equal to 15 over 52 cosine x plus 3 over 52 sine x. And then we write the general solution. Will be a particular, complementary solution or homogeneous solution, and then particular solution 1 and particular solution 2. Put all of that together, we have C1 e to the x, C2 x e to the x, and C3 e to the negative 5x. Particular solution number 1, 7/16 e to the negative x. And particular solution number 2, 15/52 cosine x plus 3/52 sine x. And that's what we have for this problem. I will zoom out so we have the whole problem on one page. There. So that's what we have. So we find the homogeneous solution and then particular solution with superposition principle. And finally, we put all of that together, and then we have the solution.